These are notes number 13, the first notes in Edpuzzle for this week. You should already have this written down, and this should all be finished from our warm-up in class. So again, these are from the book 3-4, using corresponding parts of congruent triangles. And the essential question, how do I use CPCTC to prove parts of two triangles are congruent? And you can follow along with the book. It's on page 148. And we will do problems in the book at the end. All right, so go ahead and copy this down. Pause if you need to. I'll read through it. So if you need a little more time, pause it. Okay, so today's lesson is all about proofs. So in the book, it's all proofs. In the notes, I did, instead of proofs, just kind of short little proofs, not real proofs. So one thing to really keep in mind is when you're proving two triangles are congruent, remember to use SSS, side, 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 SAS, side, angle, side, ASA, which is angle, side, angle, and AAS, angle, angle, side, and the HL, hypotenuse, leg theorems and postulates to prove two triangles are congruent. In our proofs, you will prove two triangles are congruent. So one of your reasons will be like one of these. And then there's one last step, which is the CPCTC. So you're going to prove two triangles are congruent, and then one more step, you'll prove that parts of the triangle are congruent using the CPCTC. And as you're going through proofs, like I've been saying a lot in the notes, let me just show everything there. Don't forget vertical angles are congruent. So don't forget this. Vertical angles are congruent, and the reflexive property when we have a shared side. So we will do this a lot. You'll learn it as we do more and more repetition. So with two triangles, they might have vertical angles, and those are congruent. That's a reason in a proof. And we also have the reflexive property anytime they share a side. Okay, so like I was saying, once you know two triangles are congruent, then you can conclude, you can prove that corresponding parts of congruent triangles are congruent, or CPCTC for short. So you can tell every time we write corresponding parts of congruent triangles are congruent, that's a lot. It takes more than one line to write. That's why we say CPCTC for short. So practice saying that, CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so C is for corresponding, P is for parts, congruent, triangles, congruent. It's a lot to say, so even though it's a longer abbreviation, it's way shorter. Okay, so again, we are going to use this. The CPCTC will use that once we know already and we have proven that we do have two congruent triangles. Okay, so here's one example. So pause if you need to, and we'll do an example. Okay, so go ahead and draw this. It says, why is angle U congruent to angle E true? So here we have triangles. It's actually like a kite, a quadrilateral, which is called, this shape is called a kite. And it has a diagonal, which then splits it into two triangles, which appear to be congruent, but right now we only have side, side. We would need one more side or an angle to have a proof that they're congruent, or to prove it. So think about if there's another side or another angle, like what we said up here, vertical angles are congruent, or reflexive property. And once we have proven that the triangles, the top and the bottom triangles, are congruent, then we could say that angle U is right here and angle E is right here, that they are corresponding parts. See how they match? They're like the same angle, basically. Corresponding parts of congruent triangles are congruent. We could also say that about this angle down here and this angle down here, or this angle over here and this angle over here. Okay, so hopefully you're thinking, it's the reflexive property. They share a side. So you're right if that's what you're thinking. So I can do 3 marks on that shared side. So I'll just remind you guys, shared side is congruent because reflexive property. And now, which theorem or postulate proves that the triangles are congruent? So out of all of these, you have to think, oh, which one is it? So I hope you're thinking SSS. Okay, so I'm going to go ahead and write this out. I'm going to just write it in a sentence. So this, it's saying, why is that true? This is true because, oh, I don't have that much room. I'm going to just skip to here. Triangle, I'm going to name them now, and I have to name them in the correct order. So I'm going to say JUN. JUN is congruent to triangle. I'm going to say JEN, keeping them in the correct order, by side, side, side. So using CPC, TC, corresponding parts of congruent triangles are congruent. Angle U is congruent to angle E. Okay, so pause if you need to, but basically what we did is we just saw, oh yeah, there's the reflexive property, the shared side. So now we've got side, side, side. It matches with the bottom triangle, side, side, side. So when you have the two triangles congruent, you can then say any of the other corresponding parts are congruent. So those two angles are congruent, which is what it asked me for. But like I was saying, it's also this angle over here or this angle over here, 1, 2, 3, 1, 2, 3. And you have to mark the 3 angles differently. So 1 mark there, 2 marks there, 3 marks on that one, even though it's kind of hard to see. Okay, so let's try that one more time with another example. So again, you guys can pause as needed. Okay, and okay, same kind of question, it's just different diagram. So it's asking, let me just separate that. Why is segment EA congruent to segment MA true? So in my mind, I'm thinking, well, I have to prove these two triangles are congruent. And once I do that, then I can say CPCTC proves that corresponding segments of congruent triangles are congruent. So once you've proven that the triangles are congruent, all of the corresponding or like the matching up angles or sides are then congruent as well. Okay, so let's go ahead and see what information we've got. Again, make sure you draw this. It's like one triangle, drop it down in the middle. We've got one side marked congruent and one angle. So I can kind of tell it's like if you reflected this triangle and flipped it back over, they'd match up perfectly. Okay, so what we're missing is we're missing this side in the middle. And I'm noticing that's the reflexive property again. So every time you see that shared side, think reflexive property. So now you have to think, how are these two triangles congruent? Which one from up here can I use? Is it side, 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 angle, side, angle, or angle, angle, side? Or maybe they're right triangles and it's the hypotenuse-leg theorem. So I don't have right angles. I know it's not HL. So I see a side, angle, side, matching up here, side, angle, side. So they're congruent by side, angle, side. So I'm going to answer the question, why is that true? I'm going to say, this is true because, let me put the triangle congruent statement. So I'm going to say triangle ETA is congruent to triangle corresponding to E is MTA by, and we said already it's side, angle, side. So using CPCTC, corresponding parts of congruent triangles are congruent. Segment EA is congruent to segment MA. And I want to mark it just to see that they should be the corresponding sides. So EA is here. I'll mark it with 2. Oh, 3. And then MA is right here, 1, 2, 3. Okay, so I was able to prove that the two triangles are congruent because of the reflexive property. And then just like up above, I just didn't want to write it again. So we have the shared side reflexive property, side angle side. So the triangles are congruent by side angle side. So then using CPCTC, all of the other sides and angles are also congruent. So I've also got angle E is congruent to angle M. Mark those with 2 arcs. And then the other angle is right down there. I'm not going to mark it because it's getting too messy, but right there and right there, they're also congruent. Okay, so that's it for the actual written notes. We do have bookwork now. So the bookwork is on page 148 and 149. So I'm going to go ahead and change to the book. Pause if you need to finish writing. All right, so here we are. This is page 148 in the book. And feel free to read the part above. It's in this little paragraph right up here. It's pretty important, but we basically went over that in the notes. So set up for a 2-column proof where we have statements on the left, reasons on the right. And pause as needed. I'm going to start writing in the given information. And as you think about your given information, you want to make sure that it is marked on the diagram. So I'm going to write it and then I'm going to check and make sure I understand it. And I also want to see what is it that I'm trying to prove. So what I'm doing right now, you don't even really have to think about, you just copy down the given information. And then somewhere down at the very end, whatever I'm trying to prove, I'm going to put last. And I have a feeling, since this is in CPCTC section, the reason for that statement, that last statement, the reason over here will be CPCTC. Okay. So let's go ahead and look at what's going on in this proof. So we have that BA is congruent to DA. That's this one, BA and DA. So I'm just going through and marking it so that I understand it, even though it's already marked. And then they have segment or side CA congruent to segment EA. So that's this one and this one. So far, they have marked 2 sides of each triangle congruent, but there is no side. I need like side or side angle side. Okay, what I need to prove, let me use a different color for that. I need to prove angle C is congruent to angle E. So that's this one and this one. They look like they are corresponding. However, I don't know that they're congruent until I have proven that these triangles are congruent. So what I want you guys to notice is, looking at this diagram, what else do we know that's congruent? Nothing else is given. Nothing else is marked. But I do have special angles here at A. So what I have is vertical angles. And so if I have vertical angles, I'm kind of going to plan before I write it. If I mark these 2 angles, I would then have side angle side. Once I have proven these 2 triangles are congruent by side angle side, then I can say angle C, I can do the proof part. Angle C is congruent to angle E by CPCTC. So by planning it ahead, I can pretty much just finish it at that point. So for number 3, I'm going to name those 2 angles. I can't just say angle A because at A, there's actually 4 angles, top, bottom, left, and right. So I have to use the 3 letters to name them. So I could say CAB or BAC. I'll just say CAB. Angle CAB is congruent, corresponding to C is E, so EAD. And the reason, oh, by the way, remember that on PowerSchool I have the list. So anytime you're not sure about a theorem or a definition, we can look here. And so there is the vertical angles are congruent, the vertical angles theorem. Just to remember that that is a reason that you can put. So I'm going to go ahead and write that. Vertical angles are congruent. And again, like I said in my plan, I was like, okay, so now that I have an angle, it's side angle side. So I can just go straight to saying which triangle is congruent to which triangle. And I can actually just copy the order of the letters from up above. You could change them if you want to, but they're already in like corresponding order because I was very careful. And you can double check it. So triangle CAB is congruent to triangle EAD. So I can tell that they do match up with their corresponding points and sides and angles. The reason is side angle side. And then the last thing, like I said, once you have proven triangles are congruent, you can go to the proving any kind of a part from the two triangles is then congruent. So we could have, instead of proving angle C is congruent to angle E, it could have been a segment, like segment CB is congruent to segment ED. It could have been that. It doesn't matter. It's any of the parts of the triangles that are corresponding. CPCTC. Sorry, moving on to this next one. I want to work on this developing proof, and then we'll do one more after this. So here we have two triangles. It says, tell why the two triangles are congruent. Based on their markings, tell why they are congruent. Give the congruent statement. Then list all the other corresponding parts of the triangles that are congruent. So I'm going to break this down into 1, why are they congruent? 2, give the congruent statement. So triangle something is congruent to triangle something. And then 3 is to tell all the other congruent parts of the triangles that are congruent, all of the other angles and sides. So number 1, why are they congruent? So look at what's marked. Look at what sides and what angles are marked. We have side, 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 angle, side, angle, side, angle, 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 side. We have HL. I might have missed one, but out of those, you can tell it's side, angle, side. Matches up here with the side, angle, side. Now name them congruent. So if I name this first one, I'm going to go KLJ. Remember, the first one doesn't matter so much, but once I've picked that order, I have to match it over here. I started with K, which has the two sides with no marks and 1. So that would be like O, no marks and 1. So if I start at O, then I would go up to M and then N, O, M, N. So you have to have them in the correct order. So now I have to name all of the other corresponding parts of the triangles that are congruent. So like in the proof we just did, we named angles that are congruent. There's also sides too. So I can see angle J, I'm going to mark with 2, is congruent to angle N. Angle J congruent to angle N. And then I have 1, 2, 3. Angle K is congruent to angle 1, 2, 3, angle O. Pause it if I'm going too fast, I probably am. And then there's one more side. I have to mark 3 marks, so I'm just going to use my pen. 1, 2, 3, and 1, 2, 3. So I have KJ segment congruent to, K is congruent to O, so I'm going to say ON because order matters, ON segment. So we had a side and an angle and a side marked, but there's still 2 more angles and another side. So 2 angles and a side, 3 sides and 3 angles in a triangle. Okay. And then here's our last one. We're going to do this proof. So it says proving triangle parts to measure distance. This problem's based on a word problem from this book, but you have to go online to see it. So we're not going to worry about the word problem part. We're just going to go straight to the proof. Okay, so I set up my 2 columns real quick for statements and reasons. Go ahead and set that up, and I'm going to start by just copying the given down. Again, you don't even have to think, you just copy whatever the given says, and then I'm going to make a plan after I copy the given, a plan to solve. Okay, so there's my 2 givens. I'm going to go make sure that they are marked, and I want to understand. So what I see here, I see one big long triangle. Based on its markings, it's actually an isosceles triangle. And then it has a line going from A to M, and that separates it into a top and a bottom triangle, which shares a side. So there is a shared side. Okay, so based on the given, it says segment AB is congruent to segment AC. So they already marked it, but I'm just checking it. The other piece of information is one of our definitions. M is the midpoint of BC. So M right here is the midpoint of this segment BC. I'm going to look back at the list and show you guys what is the definition of a midpoint. This could be a reason and a proof. It says two congruent segments. So remember, you can see this list on PowerSchool on our weekly page all the time. I keep copying it on there. So M is the midpoint of AB. That means that you have two congruent segments. AM is congruent to MB. Midpoint gives us two congruent segments. Okay, so looking at this example, if M is the midpoint, then I have BM congruent to CM. It's kind of hard to tell, but I did two markings because there's already one right there. And I got all that just from this one part in the given. So what I need to prove, I do want to see what is it that I'm trying to prove. Angle AMB is congruent to angle AMC. So AMB, that's this angle, is congruent to angle AMC. They seem like they are corresponding, but I can't prove that until I have to first prove the triangles are congruent, and then we'll do CPCTC. So let's prove that the triangles are congruent. That way I can use the corresponding parts of congruent triangles are congruent. So the last thing I wrote in my statements is that M is the midpoint of BC. So what I'm going to use is the definition of midpoint as my reason. So see how it kind of gives me a hint of the next step. Midpoint, definition of midpoint. So that would tell me that the two segments are congruent. And I already marked them, but I have to put them in the proof. So segment BM is congruent to segment CM. Looking at my diagram, I have one side and the second side. I need to prove angles. So it's not side-side angle. I need to prove the angle. I did notice earlier that they share a side. So that will be another thing I can put in the proof. So 1, 2, 3, that they have that shared side AM. 4 is AM is congruent to AM. You guys should know by now, because we've done it enough, that is the reflexive property. Okay, so now that I have the reflexive property from the shared side, I have one side, a second side, and a third side. I'm trying to prove angles are congruent using CPCTC. So I am ready now for statement 5, that the triangles are congruent. So I'm going to start at A, go ABM is congruent to ACM. And you can tell that that is side, side, side. And I almost could fit it, but I wrote a little too much. So now we're at step 6, our last step. So now that I have proven that these two triangles are congruent by side, 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 I can use, I already know my reason, it's going to be CPC, TC. Corresponding parts of congruent triangles are congruent. Any other part of these two triangles is congruent. So yeah, of course, I can prove angle AMB is congruent to angle AMC. Whoops, you can't see that. There we go. Okay, so there's that last step. Okay, so that is it for the bookwork. Make sure when you turn these in at the end of the week that you have your notes as well as pictures of the bookwork. And I'm also going to make an ALEKS help video. So if you do need help when you're working on ALEKS, this would be ALEKS number 13. Please watch the help video because it will make a lot more sense if you have the video helping you along with as you're trying the homework. Okay? So good luck. I know you guys can do it. And make sure you finish up your notes with questions and a summary. 3 questions on the left and 1 3-sentence summary explaining what you learned, answering the essential question.